Hi, I'm Brandon Gracely. I'm a high school math teacher, and we are going to learn about differences of squares and how to factor when we have that situation. So let's start with the opposite end. We'll take two binomials and expand them, multiplying these two binomials, x plus 2 times x minus 2. And the key thing here is noticing that I've got the same values here and here with different signs, and also the x's are the same here. So let's try this out. X squared, we've got plus 2x, we've got minus 2x, and minus 4. And as usual, we notice what's happening in the middle. We've got two terms with an x value. Simplifying, we have x squared. Those are opposites, so they kind of cancel each other out, and we're left with x squared minus 4. Now this is x squared, and this is 2 squared because I've got a 2 here and a 2 here. These are squares, and there's a minus sign in between. That's why we call it a difference of squares. The two squares subtracted. In fact, this works anytime you have two expressions like this multiplied together, two binomials. I'm going to put the general value b here. X plus b times x minus b is x squared plus bx minus bx, those cancel, minus b squared. So when we clean that up, x squared minus b squared. So if you have x squared minus b squared for any value here or here, it works out like this: x plus b, x minus b. Whatever is being subtracted has you add it here and you subtract it there. And so let's try something larger. We'll do 2x minus 3 and 2x plus 3. Oh, sorry about that. So I have the same situation here. The same number or expression term is here at the front of each binomial, and then the back half of each binomial I've got minus something and plus that same thing. Expanding this out, 2x, let me show you with the arrows here, 2x times 2x, that is, I'm just going to write it like this for now, 2x squared, and then I've got 2x times 3 is going to be 6x. Here I've got negative 3 times 2x is negative 6x. And the last part, negative 3 times positive 3 is minus 9. Finishing that off, 4x squared minus 9. And the other way to write that is 2x all squared, 2 squared and the x squared, minus 9. And so you can see here, this is something squared, and this 9 is 3 squared. So this is a difference of squares. To work backwards, we would get something like that. This always works for any kind of difference of squares that you have. So let's start with something like this and work backwards. So what if I have 25x squared, so that's a square, minus some other square, let's pick 64. So you've got to know your squares to be able to do this. This 25 is 5 times 5, so 5 squared is 25. X is squared, so that is a square. I'm just going to rewrite it over here for you. That is 5 times x, all squared. And this one here, 64, is 8 squared. So I've rewritten this expression showing you the two pieces that are squares here. All right, we're going to have the front number, the positive number here, the square root of that written out at the front of each binomial. And the back of each binomial, we're going to take the square root of this, 8, have a positive version of it and a negative version of it. And if you were to expand this back out again using binomial expansion rules, you would get back to this 25x squared minus 64. So that's a difference of squares. Anytime you have a square minus another square, take the square root of both of them and you just set it up this way. One plus the other, and then the first one minus the other. Okay, hopefully that's good for you, and let me know if you have any questions.